Let's now follow our Data Explorer's motto of visualizing our transformed images. So we saw what it looks like to pass one image through a data transform. And if we wanted to find more documentation on Torch Vision transforms, where could we go? There's a lot of these. So transforming and augmenting images. This is actually going to be your extra curriculum for this video. So transforms are common image transformations available in the transforms module. They can be chained together using Compose, which is what we've already done. Beautiful. And so if you'd like to go through all of these, there's a whole bunch of different transforms that you can do, including some data augmentation transforms. And then if you'd like to see them visually, I'd encourage you to check out illustration of transforms. But let's write some code to explore our own transform visually first. So I'll leave this as a link. So I'll go up here, right here. Transforms help you get your images ready to be used with a model / perform data augmentation. Wonderful. So we've got a way to turn images into tensors. That's what we want for our model. We want our images as PyTorch tensors. The same goes for any other data type that you're working with. But now I'd just like to visualize what it looks like if we plot a number of transformed images. So we're going to make a function here that takes in some image paths, a transform, a number of images to transform at a time, and a random seed here because we're going to harness the power of randomness, and sometimes we want to set the seed, sometimes we don't. So we have an image path list that we've created before, which is just all of the image paths that we have of our data set. So data, pizza, steak, sushi. Now, how about we select some random image paths and then take the image from that path, run it through our data transform, and then compare the original image of what it looks like and the transformed image and what that looks like. Let's give it a try, hey? So I'm going to write a doc string of what this does, and then selects random images from a path of images and loads / transforms them, then plots the original versus the transformed version. So that's quite a long doc string, but that'll be enough. We could put in some stuff for the image paths, transforms, and seed. We'll just code this out. Let's go random seed. We'll create the seed. Or maybe we do it if seed, random seed. Let's put that. And we'll set seed to equal none by default. That way we can, we'll see if this works, hey? If in doubt, code it out. Random image paths, and then we're going to go random sample from the image paths and the number of sample that we're going to do. So random sample is going to, this will be a list. I'll just pass in here that this is a list. So we're going to randomly sample k, which is going to be n, so 3 images from our image path list. And then we're going to go for image path. We're going to loop through the randomly sampled image paths. You know how much I love harnessing the power of randomness for visualization. So for image path in random image paths, let's open up that image using pill. Image.open image path as f. And then we're going to create a figure and an axis. And we're going to create a subplot with matplotlib. So subplots, and we want it to create one row. So it goes n rows, n cols. One row and n cols equals 2. And then on the first, or the 0th axis, we're going to plot the original image. So imshow, we're just going to pass it straight in f. And then if we want to go ax0, we're going to set the title. So set title. We're going to set it to be the original. So we'll create this as an f string, original, and then new line. We'll create a size variable, and this is going to be f.size. So we're just getting the size attribute from our file. So we'll keep going, and we'll turn off the axes here. So axis, and we're going to set that to false. Now let's transform on the first axis plot. We're going to transform and plot target image. This is so that our images are going to be side by side, the original and the transformed version. So there's one thing that we're going to have to do. I'll code it out in the wrong way first. I think that'll be a good way to illustrate what's going on. F, so I'm just going to put a note here. Note, we will need to change shape for matplotlib, because we're going to come back here. Because what does this do? What have we noticed that our transform does? If we check the shape here, oh, excuse me, it converts our image to color channels first. Whereas matplotlib prefers color channels last. So just keep that in mind for when we're going forward. This code, I'm writing it, it will error on purpose. So transformed image, and then we're going to go ax1 as well. We're going to set the title, which is going to be transformed, and then we'll create a new line and we'll say size is going to be transformed image dot shape. Oh, probably a bit of, yeah, we could probably go shape here. And then finally, we're going to go ax1. We're going to turn the axis, we're going to set that to false. You can also set it to off. So you could write false or you could write off. You might see that, different versions of that somewhere. And I'm going to write a super title here, which we'll see what this looks like. Class is going to be image path. So we're getting the target image path, and we're just going to get the attribute or the parent attribute and then the stem attribute from that, just like we did before to get the class name. And then I'm going to set this to a larger font size so that we make some nice looking plots, right? If we're going to visualize our data, we might as well make our plots visually appealing. So let's plot some transformed data or transformed images. So image paths, we're going to set this to image path list, which is just the variable we have down below, which is a path list, a list containing all of our image paths. Our transform, we're going to set our transform to be equal to our data transform. So this just means that if we pass the transform in, our image is going to go through that transform and then go through all of these. It's going to be resized, it's going to be randomly horizontally flipped, and it's going to be converted to a tensor. And then, so we're going to set that data transfer there, or data transform, sorry. N is going to be 3, so we plot 3 images, and we'll set the seed to 42 to begin with. Let's see if this works. Oh, what did we get wrong? We have invalid shape. As I said, I love seeing this error because we have seen this error many times and we know what to do with it. We know that we have to rearrange the shapes of our data in some way, shape, or form. Wow, I said shape a lot there. That's all right. Let's go here, permute. This is what we have to do. We have to permute. We have to swap the order of the axes. So right now our color channels is first. So we have to bring this color channel axis or dimension to the end. So we need to shuffle these across. So 64 into here, 64 into here, and 3 on the end. We need to, in other words, turn it from color channels first to color channels last. So we can do that by permuting it to have the first axis come now in the 0 dimension spot. And then number 2 is going to be in the first dimension spot. And then number 0 is going to be at the back end. So this is essentially going from C, H, W, and we're just changing the order to be H, W, C. So the exact same data is going to be within that tensor. We're just changing the order of the dimensions. Let's see if this works. Woohoo! Look at that. Oh, I love seeing some manipulated data. We have a class of pizza and the original image is there and it's 512 by 512, but then we've resized it using our transform. Notice that it's a lot more pixelated now, but that makes sense because it's only 64 pixels. Now, why might we do such a thing? Well, one, is this image still look like that? Well, to me, it still does, but the most important thing will be, does it look like that to our model? Does it still look like the original to our model? Now, 64 by 64, there is less information encoded in this image. So our model will be able to compute faster on images of this size. However, we may lose some performance because not as much information is encoded as the original image. Again, the size of an image is something that you can control. You can set it to be a hyperparameter. You can tune the size to see if it improves your model. But I've just decided to go 64:3 in line with the CNN Explainer website. So a little hint, we're going to be re-replicating this model that we've done before. Now you notice that our images are now the same size, 64:64:3, as what the CNN Explainer model uses. So that's where I've got that from. But again, you could change this to size to whatever you want. And we see, oh, we've got a stake image here, and you notice that our image has been flipped on the horizontal. So the horizontal axis, our image has just been flipped, same with this one here. So this is the power of torch transforms. Now there are a lot more transforms, as I said. You can go through them here to have a look at what's going on. Illustrations of transforms is a great place. So there's resize, there's center crop, you can crop your images, you can crop 5 different locations, you can do grayscale, you can change the color, a whole bunch of different things. I'd encourage you to check this out. That's your extra curriculum for this video. But now that we've visualized a transform, this is what I hinted at before, that we're going to use this transform for when we load all of our images into a Torch dataset. So I just wanted to make sure that they had been visualized first. We're going to use our data transform in the next video when we load all of our data using a torchvision.datasets helper function. So let's give that a go. I'll see you in the next video.